आज हम स्टार्ट करेंगे कंसेप्ट ऑफ वेव पैकेट। सो आप सबने देखा कि वेव पैकेट क्या होता है, आप लोगों को पता तो होगा कंसेप्ट बिहाइंड वेव पैकेट। सो एक इंटरेस्टिंग फैक्ट है, जैसे हमने डी ब्रोगली का एक स्टेटमेंट देखा। डी ब्रोगली में क्या बोला था? डी ब्रोगली ने कहा कि एवरी मैटर पार्टिकल हैज़ ए वेव, एवरी मैटर पार्टिकल हैज़ ए वेव एसोसिएटेड विद इट हैज़ ए वेव। ओके, सो ये डी ब्रोगली ने बोला। अब अगर ऐसा है कि हर एक मैटर पार्टिकल के पास में कोई वेव है तो उसकी कोई फेज वेलोसिटी भी होगी। सो आगे इसके अंदर एक वेरी बिग कॉन्ट्राडिक्शन हमें देखने को मिलेगा। उस कॉन्ट्राडिक्शन से शुरुआत होगा क्वांटम मैकेनिक्स का। ठीक है, तो देखिएगा, सबसे पहले हम बात कर रहे हैं कि डी ब्रोगली ने ये बोल दिया, तो इसके लिए हम एक कंसिडर कर रहे हैं जैसे साइन कोई वेव फंक्शन लाइक ए साइन ओमेगा टी माइनस के एक्स। सो व्हाट द फेज वेलोसिटी फॉर दिस वेव फंक्शन? आपको पता है फेज क्या है? ओमेगा टी माइनस के एक्स। ये हमने फेज ले लिया और इसको मान लिया एक कॉन्स्टेंट के इक्वल। सो वी आर like derivating this with respect to, okay, like this is omega dt and this is k dx. It is 0 because constant derivative is 0. So in the next step I am saying that dx over dt is simply omega upon k. So this is what? This is the where phase velocity. Okay, simply the phase velocity. So we are saying vp is equal to omega upon k. But now the contradiction is coming from this term. Okay, like we are multiplying h cross omega, h cross k, both will multiplied h cross. So what is the h cross omega? H cross is the omega is simply mc square and h cross k is simply momentum, which is mv, you know. So mm is cancelled, the vp, the phase velocity is coming out c squared upon v. So what you will see here, the like we will take c common out and c upon v. Now we are saying that c upon v, what do you understand by c upon v? C upon v is greater than v by Einstein. Einstein जी ने क्या बोला था कि for every like particle, any particle can't have velocity greater than c. नहीं हो सकता ऐसा। उसने बोला कि velocity किसी भी पार्टिकल का c से ज़्यादा नहीं हो सकता। इट मीन्स क्या हुआ कि c upon v हमेशा 1 से बड़ा रहेगा। If the c upon v is greater than 1, then what? Vp is greater than c. From this line we can see this is greater than 1, it means this is Vp is greater than c. But this cannot be happen by Einstein. So something is wrong here, something is done wrong here. So यहाँ से निकल के आते हैं कि Vp like इस डेरिवेशन से पता क्या चला कि Vp बड़ा है c से और c बड़ा है v से। बट ये तो गलत हुआ। इसका मतलब ये हुआ कि देयर इज नॉट ए सिंगल वेव। डी ब्रोगली ने क्या बोला कि हर एक पार्टिकल के साथ में वेव एसोसिएटेड है दैट साइड, बट नॉट अ सिंगल वेव। ये वहाँ पे एक लाइक अंडरस्टैंडिंग लाइक एक छुपी हुई बात थी जो कि तब पता नहीं चली थी। तो डी ब्रोगली की बात कुछ हद तक सही थी कि वहाँ पे वेव तो एसोसिएटेड है, बट उसने ये नहीं बताया कि सिंगल वेव है या नहीं। सो ये बात पता चली यहाँ से कि भैया फेज वेलोसिटी तो ज़्यादा नहीं हो सकता, फेज वेलोसिटी लाइट की स्पीड से ज़्यादा नहीं हो सकता। इट मीन्स क्या कि वहाँ पे एक सिंगल वेव नहीं है, वहाँ पे एक ग्रुप ऑफ वेव प्रेजेंट है, ग्रुप ऑफ वेव, जिसको हमने क्या बोला? वेव पैकेट। ओके, वेव पैकेट। ओके, वेरी बेसिक लाइक वेव पैकेट का इनिशियल स्टेज कहाँ से है, तो वो यही था कि वीपी ग्रेटर देन वी आर। ठीक है, नाउ हमारे पास एक एग्जांपल लेते हैं कि अगर हमने बोल दिया कि वहाँ पे एक वेव नहीं है, इट मीन्स वहाँ पे कई सारी वेव हैं, तो हम मान रहे हैं कोई भी 2 वेव लेके हम इससे देख रहे हैं कैसा क्या रिजल्ट आ रहा है। So we are taking a sin omega 1t minus k1x, ये हमने एक वेव ले लिया। एंड दूसरा वेव दूसरे पार्टिकल से एसोसिएटेड ले रहे हैं हम, दैट इज a sin omega 2t minus k2x. Now what we will do, we will superimpose these two waves. Okay, we will superimpose like superposition. We will do the superposition of two waves. What we will get here? So do the superposition, psi is equal to psi 1 plus psi 2. Then simple. Now you will add these two things. So we will get a of sine omega 1t minus k1x plus sine omega 2t minus k2x. Okay, very simple. Now what you will see, you know sine a minus sine a plus sine b formula. So that you all know, like what is the sine a plus b formula? Sine a plus sine b is equal to 2 of sine a plus b by 2 and cos of a minus b by 2. So this formula this identity formula we will use here, okay, because this is a, like for angle, this is b. So we will put this a b in this formula, and what we will get, let's see, 2a sine of omega 1 plus omega 2 by 2 into t minus k1 plus k2 by 2 into x, okay, plus and then into because there is multiplied, okay. So cos of omega 1 minus omega 2 by 2t minus k1 plus k2 divided by 2 of x. There is an x in the right side, okay. There is an x and we're writing here. So what you see from here, like we are assuming that omega 1 and omega 2 are for same particle, we are writing two waves, okay. So we are taking the omega 1 is approximated equal to omega 2, okay. So for that k1 is equal to k2, nearly equal. So from that we can say the omega 1 minus omega 2 is delta omega, and omega plus omega 2 is like 2 omega, 2k, like this, same thing, okay. There is a minus sign, so this will be delta k. So we are putting the values here by approximation. So what we will get, sine is equal to 2k cos of del omega. We are writing the first term in the second term in the first, okay. So del omega t minus del k of x. There is a sine term omega t minus of kx. So what we are getting, this is the superposition wave, okay. Like by the, we are taking this two waves initially, and after superposition we are getting this. So what represent this? This represent, this is amplitude. This behaves like an amplitude because these are very small. These are small values, and small values mean the cos value is high. So this is approximated over the amplitude, okay, amplitude, and this is the wave. So if we draw this graph, so what you will get, we will get something like this, okay. Let's see, the amplitude is increasing and decreasing, and again it is increasing and again it decreasing, okay. My diagram is not so good, but you can understand it like this. So what you understand by this thing, this is the group wave, okay. This is the group wave, like amplitude, and this is the particular wave, okay. So for this wave, the velocity should be called Vp, particular phase velocity, and this wave should be called group velocity because this represents the group of wave, okay, group of wave, understand. So for the group velocity, what we will do, we will do like this term represent the group, and this term is represent this whole wave. So for the group velocity, the cos part should be delta omega t minus delta kx should be constant, okay, for the group velocity. So what will be done, delta omega over delta k is simply the dx over dt. Understand this thing? We are derivating this term, and after derivative you are getting this, and this is called Vg, which is called delta omega over del k is the group velocity, okay. This is the group velocity. Now the next term is the we can convert it in the easiest form, like Vg is called, we can say dh cross omega, dh cross k. So what we will done, this is d over dp. It is same now, because h cross omega is represent the energy and h cross t is the represent momentum, okay. So this is the Vg in the different energy and momentum form, okay. So okay, now we are taking two cases. Case first here, case first is for non-relativistic. We will calculate the group and group velocity for the two cases, which is first is non-relativistic and case second is for relativistic, or the relativistic. For non-relativistic case, we are saying the energy is equal to p square by 2m. So what is the dE upon dP? You can say from here that p square, like what is the derivative of p square? 2p, and 2p upon 2m is the constant, m is cancelled, p upon m. What is this momentum? Momentum is mass into velocity. So mass is cancelled. So what you will get, d upon dt. So we are getting, this is v. It means the Vg is equal to Vp, V. Okay, the Vg is equal to V. So in the first case, our non-relative case, the group velocity is equal to V. Okay, in the second case, what we are getting? Let's see. P square is equal to P square plus M naught square C4. In the relativistic, you know the what is the energy expression. This is the energy expression. So if we derivate this to dE is equal to 2P dP into C square plus some constant, because M naught square C square not contain P term. Okay. So what is the dE upon dP here? We can see this is P upon E into C square. Okay, into C square. So what is the E here? So E is simply MC square in the relativistic case. So dE upon dP is what? So we can say like P is mv C square. So cancel. The C square cancel. This is equal to V. From here also we can say the group velocity is equal to V. So in the both relativistic and non-relativistic, we are getting the same group velocity. Okay, same group velocity V. Now, what is the relation between Vg and Vp? Okay. So we are saying what is the relation between Vp and Vp. So let's see. Vp is equal to omega by k, and omega is equal to Vp into k. We are just doing some calculation. After that, we will get relation. Okay. So we are derivating respect to k. So d omega over dk is equal to Vp plus k, because we are taking k. So k derivative is 1 here, and k into dvp over dk. Very simple. No doubt. Okay. So what is this? D omega over dk is equal to the group velocity, the Vp is the phase velocity, plus k dvp over dk is the relation between the group velocity and phase velocity. Okay. Now we will do one more thing here, that we know that k is what? 2 pi over lambda, simply. So what is the dk here? Dk is simply minus 2 pi over lambda square and d lambda. So if I put like dk is equal to minus k d lambda over lambda. Okay, I can write now, because k is what? 2 pi upon lambda. So I replaced like 2 pi and lambda, I replaced by k. So dk is equal to this. So what my dk over k is equal to minus d lambda over lambda. Very simple. So now I'm putting here dk over k. So Vg is equal to what? Become Vp minus lambda dpp upon d lambda. It is the relation between Vg and Vp in respect to, like, derivative with respect to lambda, here that with respect to k. That okay. So we've done this, and now we are finishing this, because in the next lecture we will see in the particular cases for normal dispersion, there should be a dispersion topic will come in the next topic. Okay. So till now, if you have any doubt, you can comment me, or you can ask me on the mail.